We are setting standard music theory aside to build the complete continuous harmonic structure of the fretboard from scratch, using only primitive mathematics. The entire architecture begins with a single source identity, the number 1. This is the starting condition of the system, existing before any patterns are formed or any routes are built. Expanding this single identity into a linear sequence of 12 points presents a structural limitation. When a route reaches the end, it hits a hard edge and stops. By wrapping the sequence into a 360-degree ring, the line becomes a continuous geometric loop. This structure, the K12 chromatic field, functions as a mathematical engine governed by modular arithmetic. It is a coordinate map where every position is a recurring station. Establishing this closed symmetrical ring is the required foundation for the system. Without it, the geometric relationships and scales that follow have no field to inhabit. We probe the K12 field by applying constant step traversal operators called N extractions. These operators move through the 12 nodes using a fixed step size to reveal the internal structure of the circle. When we walk the field in steps of 2, an N2 extraction, the 12 nodes split into 2 separate 6-node cycles, drawing a perfect hexagon. Increasing the step size to 3, the N3 extraction, divides the field into 4 4-node cycles, generating the geometry of a square. Moving in steps of 4 creates 4 3-node cycles. This N4 extraction locks the field into a triangle. A step size of 5 is coprime to 12, meaning the two numbers share no common divisors. Because of this, an N5 extraction contacts every node in the field before closing, weaving a continuous 12-point star. An N6 extraction steps exactly halfway across the circle. It connects opposite nodes to expose the central axis of the system, the tritone spoke. These shapes are the rigid geometric consequences of dividing a closed 12-node field. They are mathematical facts revealed by the step size of the operator. We now unwinding these two-dimensional shapes into one-dimensional linear pathways called walk cells. When we unspool the N4 triangle into a straight line, it produces a repeating sequence of 2 steps, then 1 step. This 2-1 pattern forms the minor walk cell. Unspooling the N3 square results in a sequence of 2 steps, and then 1 step. This 2-2-1 pattern forms the major walk cell. To link these isolated walk cells into infinite chains, the system uses an implied +2 handoff step, which acts as a mechanical bridge between the end of one cell and the start of the next. As these cells stitch together, they generate the intertwined numerical braids of 23 and 32. These linear patterns, often categorized as scales, are the unspooled representations of the original geometric partitions. The numerical sequences 34 and 43 provide the interval mathematics required to map these braids across physical instrument strings. This mapping is governed by the master separation lock. This rule requires that we track interval mathematics and physical string geometry as 2 independent layers. Mathematically, 34 drives the overlapping chord scale. By interleaving reference rows, this 3-4 interval logic automatically generates a continuous stream of alternating triads. Physically, 34 serves as the transversal block. It functions like a jigsaw piece, dictating the exact coordinates for the fingers to step across strings, replacing the static constraints of the traditional scale box. While the physical execution and the harmonic intervals must synchronize, the system relies on keeping these two operators separate. Completing the 34 derivation produces a continuous harmonic spine, containing 24 overlapping representations. This spine is perfectly symmetrical, containing 12 major and 12 minor chord structures in a single alternating stream. Seeding these streams onto their physical anchor fields reveals a precise numerical reciprocity between the two systems. The continuous minor stream is exactly 36 notes long, but it sits on a physical scaffolding of 48 augmented anchor units. In contrast, the continuous major stream is 48 notes long, but it sits on a scaffolding of 36 diminished units. The stream lengths and the unit counts of their physical coverings perfectly swap the numbers 36 and 48. This numerical inversion identifies the major and minor scales as reciprocal halves of the same geometric engine. We reach the final capacity of the system by sliding a phase analysis window across both continuous streams. Sliding a 4-note window across the major stream reveals 4 phase cycles. Multiplying these 4 cycles by the 36 physical units yields exactly 144 continuous major readings. A 3-note window on the minor stream reveals 3 phase cycles. Multiplying these by the 48 physical units also yields 144 continuous minor readings. Combining these results identifies the total capacity of the system, exactly 288 continuous scale pathways. At 288 pathways, the flat coordinate plane reaches a saturation point. In 2 dimensions, these paths would physically overlap, obscuring their individual identities. To preserve every unique route while maintaining circular symmetry, the mathematics projects the grid onto a 3rd axis, inflating the map into a volumetric sphere. This 3-dimensional sphere of overlapping rings contains every possible harmonic contact and traversal route in the 12-pitch system. The fretboard is a deterministically governed geometric topology. We have generated its entire 288-path architecture from a single primitive numerical point.